Alright, so today for Algebra 2, what we're looking at is 13.4. And we're going to talk about some descriptive statistics. Now, the first set of statistics you guys have seen before. And so what we're talking about with a statistic is we're talking about a number that's going to describe a data set. So when we're talking about statistics, this way we're talking about a characteristic of a data set. And the most common statistics that we're going to deal with are measures of center. And these are the ones that you guys have already seen. So the measures of center are mean, median, and mode. And there is another one which is hardly ever used, but that's called the mid-range. And it's so hardly used that your book doesn't even mention it. So that's why I put the asterisk here to know that we'd probably get rid of that one. It's not very accurate, but it's nice to know that there are other ones out there that exist. So mean, median, and mode are the three we want to focus on. And we're going to look at how we're going to calculate these. Now, you guys may have learned that the word mean is the average. You add them all up and divide by how many. So to get the statistical mean, we're going to take and we're going to add up all the values. So if we have some data set, so let's say that we have a data set S, which is made up of a whole bunch of data values. So we'll say it's made up of x sub 1, x sub 2, x sub 3, all the way up to x sub n. So we have this list of data values that we want to work with, and we want to calculate the mean. So what we're going to have to do to get the mean is we're going to have to take the sum of all those data values, and we'll use our sigma notation that you guys looked at in the last section. So the sum from I equals 1 to n of all those x sub i's that make up that data set, divided by n, the number of values that we added together. So again, that's what you guys called average in the past, but we have to be careful with that word average in mathematics, because technically all three of these, or any measure of center for that matter, can be referred to as the average. So I could talk about the mode being the average value for a data set. Wouldn't be the average that you guys are thinking of, but it would still mathematically be true. So yeah, for the mean, it's just what you guys would have thought of as average in the past. x1 plus x2 plus all the way up to x sub n. And then you divide by n. So hopefully nothing new there. The median, you guys have also seen before. And the median is simply the middle value. So this middle value means that if you put all the values in order from least to greatest, so we put the data values in order, and then we choose the middle value, or if by chance there ends up being an even number of values, we might have to take the two middle values, and we might have to add those together and divide by 2. So sometimes we have to take the mean of those two middle values to get it to do what we want. And then the mode, again, should be one that you guys have worked with before. That's just the data value that shows up the most. And I'm saying data value instead of number because some of these will work even if we don't have numbers as our data set. The mode, for example, is a really good measure of center when we're measuring non-numerical data. So if we were measuring what's called qualitative data, such as if we collected everyone's favorite color or the month they were born in. Those numbers, there wouldn't really be numbers associated with that would make any sense to go through and do a calculation by adding colors or to put the colors in order from least to greatest. So mode would actually be the best measure of center for that one. So qualitative data, some things like categories, colors, and things of that nature would fit better with mode as being the measure of center. When we have numerical data or quantitative data, that's when the mean and the median would show up. Now, how to tell the difference between the mean and the median and which one would be better? Well, the mean is affected by values that don't fit the other data. So what would happen is if we have a data set where we had 1, 2, and then 38, 40, 41, 45, 45. That 1 and 2 don't seem to fit with the other data points. They're really low in comparison. So they're going to affect the mean or the mathematical average, as you guys would have called it in the past, and bring it down quite a bit. Whereas if we were looking at the median value would still be right here at 40, which would still be a pretty decent measure of center for that set. So the median handles those extreme values a little bit better. The thing the median doesn't do so well is the median might not work so well when we spread the values out a lot, or it might be a little bit more confusing when we have a lot of data values and we have to put them in order. But we'll look at some tools and tricks for putting stuff in order later and calculating these.